Welcome back. So now we're going to get started on number 11. So a pair of perpendicular lines with equations written in slope-intercept form. So remember that perpendicular lines have slopes that are negative reciprocals. All right, so I'm going to choose a pair of slopes, right? And you just got to make sure that they are negative reciprocals of one another. All right, so it means one's going to be positive, one's going to be negative. So I'm going to choose 3/4. That'll be my positive. And then my negative, I just got to flip it, negative 4/3. Right, so those slopes would be perpendicular to one another. So you choose something besides 3/4 and negative 4/3. It could be an integer value. It could be a different fraction. All right, and then you're going to, since you're writing it in slope-intercept form, you can pick the y-intercept. So I think I'll use this y-intercept right here. All right, so that's the point 0, -3. And I guess that'll be for the line that's going to have a slope of 3/4. So that means it's going to go up 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. I have enough space, I'll do that again. 1, 2, 3, 1, 2, oops, 1, 2, 3, 1, 2, 3, 4, just barely enough space. All right, and I could sort of go the other way, but I'm really running out of space there. So now I'm just going to connect the points. And you'll use a ruler, which would be better than my line tool, I'm sure. That's not too bad. All right, and then I'll write the equation. So the slope here was 3/4, right? Went up 3 to the right 4. And it has a y-intercept of -3, so in slope-intercept form. That's going to be y equals 3/4 x minus 3. All right, now let's graph the other one. I'm going to put that, right here. All right, so at 0, 2, it has a slope of -4/3, which means I go down 4, 1, 2, 3, 4, to the right 3, 1, 2, 3. And I can do that again, down 4, 1, 2, 3, 4, wow, to the right 3. I can barely do that again. Wait, oops, well, that went in the wrong spot. There we go. And I could also, do I have enough room? 1, 2, 3, 4, 1, 2, 3. I don't even think I can write up here, but it'd be up there. I don't think I can get that point there, so we'll have to forget about that point. So now let's connect our points. Oh, I'm going to have to fix that. Like I said, it'd be easier if I could use a ruler. Now I got to make sure I get it in the right spot. So it goes through all 3 of my points. There we go. All right, and I'll put arrows on that because that does keep going. Should have done that over here too. All right, and so we have a slope of -4/3. It goes down 4, 1, 2, 3, 4, to the right 3. So that's -4. And to the right 3. And so that would be the equation y equals -4/3 x plus 2, because my y-intercept is 2. If I go through any of these too fast, just let me know. I can, answer any questions you might have. Let's see. Oh, good, I have another space. So I don't have a whole lot of space here for the triangles, so let's come down here and we'll do the triangles. So we're on number 12. 4 different types of triangles, and you're going to need 6 altogether because on number 13 we have equations solving for area of 6 triangles. You can use the same triangles you draw for number 11 you can use for number, the same triangles you use for number 12 you can use for number 13 and number 14, right? And actually, if you can use it for 15 and 16, right? So with a graph a triangle, find the midpoint using the midpoint formula. You don't have to have extra triangles, right? If you want to use the same triangles for more than one thing, it's fine. Now let me give you a hint on graphing. The easiest one to graph is the scaling, all right? So now, because you're going to find the area, I'm going to give you another little hint. So area is the base times the height. If you want to make it easier to find the area, make the base either a horizontal line or a vertical line, because then you can easily find you'll be able to find your measurements without necessarily using the distance formula. And I think you might find that easier. So of course the easiest one to graph is the scalene triangle. I just have to make it not have the same length sides. And so there I graphed 3 points, and I'll just make this a line like that. So here you can tell by the slope. So I have one side be a horizontal. That'll make it easier for me to find the area. You can tell by the slope that none of these are the same length, right? And we're going to look at the distance formula, and we can use that as well. So this is my scalene triangle, right? So then I want to graph a right triangle. Well, I think we have a right triangle. We have a right triangle, and there's the last one. A little hint. Just make sure you use a vertical line and a horizontal line, right? So for instance, I probably should have put the point there first. Because if we have a horizontal line and a vertical line, those will definitely meet at right angles. You could also use any two lines that had slopes that were negative reciprocals, right? Because perpendicular lines create right angles. But if you want to do horizontal and vertical, that would also be perpendicular to one another. And since you want one of them to be horizontal or vertical to make it easier to find the area, something like that might be a little bit easier. So there we have a right angle, a right triangle. Now an isosceles triangle, and that one's also not too hard. I'm only going to graph 4. You just repeat the 2 of the kinds. Do you want to, whatever one you want to repeat. And so notice if I've gone, I want to make sure my sides are the same with an isosceles triangle. So here's my middle point, right? So if I were to come straight down to where I decided I was going to draw my base, I went 1 to the left. Well, if I also go 1 to the right, I'm going to end up having a triangle with 2 sides that are congruent. All right, I went the same amount to the right and to the left. And so there is my isosceles triangle. And then finally, equilateral triangle. So again, you're going to want to make one of the sides vertical or horizontal. I'll make one vertical this time. And let me show you a really easy way that you could get an equilateral triangle. So I'll do it vertical if I can turn this around. Ugh. Well, this is going to be interesting for me. You will be able to easily turn a ruler around. So an equilateral triangle has side measures that are the, is this not going to turn? I can make it bigger. Can I turn it around? And way too small. But this is not very useful. Now I can move it. This, I think, just flips it. Where's the thing to make it move? Because I don't want to just draw vertical. I have to have some lines that are not horizontal or vertical. Well, so what you're going to do is you could just measure a distance. All right, so for instance, if I measured it 6 inches, or in this case, I guess 6 centimeters. 6 centimeters. You could then, if you were able, you could, because you can move your ruler. Which thing moves this thing? Now I remember why I never used this. Well, anyhow, I'm going to do this. I'm going to just do a cheater method here. It only works on the smartboard. Clone. Clone. All right, I now have 3 side measures. And this I can turn. I was looking for a green dot. And so you'll just pick a measurement. And, oops. You can measure 3 side lengths like that. Now I've got to make my sides. You won't have an issue with trying to get your sides to mix because you'll just draw one after the other. How long do you think this will take me? Now, every time I get one side, I mess up the other. This one's probably too far this way. Anyhow, you get the idea. You can measure. Now if you look at my, go further this way. If you notice that my height is not going to be a pretty number. So while I give up. Anyhow, they eventually will connect. You won't have that problem because you just move a ruler. And so you can use a ruler and measure to get your lengths. All right. Now notice mine. Mine are not very good lengths because none of them are integer values. So I just grabbed the ruler and did that. So I should be smart about it. And get some integer values. So I'm not going to use the ruler at all because it doesn't work for me on this anyhow. So here, if I go between integer values, right, and then you could measure that and use that to find your side measures. I'd be okay with that. And so that'd probably be the easiest way. This is the only one where, and so I'm not going to even try to make a triangle out of this because I can't use the stupid ruler. But you'll use a ruler and you'll get it the right length. So maybe it, oops, hit an arrow. Maybe it goes there. All right. So that's just eyeballing it. You'll do it more accurately because I can't use the ruler up here. That's the only one where, because it's not an integer value, I'll let you I'll be okay if you use a ruler to find your height. And the other thing you want to make sure when you're graphing these is you want them to end at integer values. So I did a good job on the scaling and the isosceles, and then didn't even think about it for the right. So I'm just going to adjust my right triangle there. So that I make sure that I have integer values. Because otherwise you're going to have a very hard time trying to figure out what your measurements are. All right, so now let's find the areas of these. So area is 1/2 base times height. And base has to be perpendicular. Oh, I didn't forget to label this one. This one was the equilateral. Before I forget. Sort of equilateral since I couldn't use a ruler. Base and height are perpendicular to one another. All right, so the height can be inside the triangle. It could be outside the triangle, depending on your triangle. All right, here it is inside. You just go from one vertex straight to the other side, to another side. All right, any side could be the base, but if you want it to be easier, make whatever was a vertical or horizontal line, make that the base. Okay? So here we have a scalene triangle. The base is 1, 2, 3, 4. Well, it's supposed to be 4. They would connect properly. It would be 4. Oops, why did I write that? Probably because I'm thinking of the next thing. And the height is 1, 2. So that means the area is 1/2 times, and I'm going to write the formula, I have it written up there. 1/2 times base times height, so 1/2 times 4 times 2. So half of 4 is 2, and 2 times 2, that's just 4. So the area is 4 units squared. All right, and so you should have the same kind of work. And this is the equation. And then just simplify. And give me these values. Your base and your height. All right, let's do the same thing for the other ones. And you can see it doesn't take that long. Area equals, so base here is 2. Height is 1, 2, 3, 4. Well, I must have liked 2 and 4, probably because these blocks are really big, so I don't have a whole lot of space. So the area is 1/2, 2 times 4. I think I know what it's going to be. So the area is 4 units squared. Hopefully, don't make all yours the same. If it ends up that you accidentally make 2 the same, it's okay. But try and make them a little bit differently. All right, so that's going through this point. I just can't seem to get either of my sides. So I got this big dot there that gets in the way to go through those points. Okay. So now let's find the area of this one. All right, so my base is 1, 2, 3, 4. And my height is 1, 2, 3, 4. So that means the area is going to be 1. Oh, let me write it down. So base is 4 and height is 4. Make sure you write them down. And so area is 1/2, 4 times 4. 4 times 4 is 16, so half of 16 is 8 units squared. The last one here, the base is easy enough to figure out. It's 1, 2, 3 units. If in trying to get your triangle to be equilateral, you end up with like this, you can measure it. And I would measure it too if I could. Now, here's another alternative. If you don't want to find, because here's my height, if you don't want to find the area of the equilateral triangle, just draw another triangle, a scalene, a right, or an isosceles, and find that area instead. Okay? So if you don't want to find the area of the equilateral triangle because chances are one of those values is not going to be very pretty, then it's fine. Draw something that will be pretty. All right. I'm going to clone this page because I'm going to use these triangles, not the equilateral one because I couldn't get my ruler to work. We're going to take the other triangles and find the lengths of the sides. All right, so we're going to use the distance formula. You don't have to use the distance formula if you've got vertical and horizontal lines. You can just write them down. Let me get rid of this. And let's find the lengths of the sides. All right, and I'll do everything but the equilateral because I don't know what this point is. And I'm okay on this one. If you, on the equilateral only, if your numbers are not going to be pretty, then you can use a ruler, but none of the other ones, all right? And then make sure you tell me what units you used, right? But all the other ones will use the coordinate plane. So I'm going to write down the points so I can use the distance formula. All right, this point here is 1, 2, so you want a coordinate. So when you're drawing these on graph paper, I almost forgot to say, make sure you've got a coordinate plane so that you can find the distance formula. All right, so make sure that there's somewhere where your triangles are, there is axes. So this point here is 1, 2, 3, negative 3, 3. This point here is negative 7, 3. And this point here is negative 6, 5. So to find the length, so I'll just call this side A, B, and C. The distance formula, it's based on Pythagorean theorem. It's the difference in the x-coordinates squared plus the difference in the y-coordinates squared. And that's it. So for A, and we'll simplify if possible. So for A, that would be negative 6, so I'll start with negative 6, 5. So negative 6 minus a negative 7, that would be a plus, squared. And then plus, I don't know if I'm going to do these all here because I don't have much space. I don't have a whole lot of space here, but I'll do a few of them anyway. And then for the y value, so that would be 5 minus 3 squared. So negative 6 plus 7, that's just 1. And 5 minus 3, that's 2. So that's going to be, oops, yeah, A's for the side. I was thinking I was writing area here. So that would be 1 plus 4 or the square root of 5. That's not going to simplify. All right, so now I don't have to worry about B because B is 1, 2, 3, 4. All right, you don't have to use the distance formula if it's a horizontal or vertical line. And then C, so that would be so I'll start with a negative 6. Negative 6 minus negative 3 squared plus, yeah, I definitely don't have enough space for all of them. Maybe I'll do the scaling and the right because I'm taking up all the space for the isosceles. Oh, by the way, on the isosceles triangle, since you know the two sides are the same, when you find one, you don't have to use the distance formula again, I guess. So this would be negative 6 minus a negative 3 squared plus, and then the y-coordinates is going to be 5 minus 3 squared. So that's going to be, that's negative 6 plus 3, so that's negative 3 squared plus 2 squared. And so that would be 9 plus 4. That's the square root of 13. That doesn't simplify. That's a prime number. All right, so there I found all three sides. So A was the square root of 5, B was 4, and C was the square root of 13. Okay. I'll also do the right triangle. Now there's no reason I'll call this side D, this side E, and this side F. All right, there's no reason to use the distance formula for a vertical line. D is 4. Same thing, horizontal line, E is 4. Now F, you have a choice. You can use the distance formula or Pythagorean theorem when you've got a right triangle. I think that I'll just use the distance formula just to show you again. All right, so this is the point 3, 1, and this is the point -1, 5. So then we have, and I'll start with -1, 5. So we have -1 minus 3 squared plus 5 minus 1 squared. So that's going to be -4 squared plus 4 squared. Says that would be just what we would get if we were using Pythagorean theorem. And that would be 16 plus 16. So that would be the square root of 32. And that square root of 32 is 16 times 2. 16 is 4 times 4. So here our answer is 4 square roots of 2. We could simplify that radical. 1 4 comes out, 1 4 goes away. And that's all there is to these ones. All right. So that'll take you through 12, 13, 14. And then I'll show you on the next video 15 and 16 real quick. All right. Thanks for watching. Bye for now.